For our group project in the discrete structure course CSC 510, we have decided to focus on the topic of properties of relation, which is question 2, and in particular to explore the concept of reflexive, symmetric, and transitive properties. Our project focuses on the development of a software program that can be used to assess whether a given set of relations satisfy the criteria of reflexivity, symmetric, and transitive. To ensure compliance with these properties, our program contains rules for reflexivity, symmetry, and transitivity. For the implementation of our project, we have chosen the programming language in C++ in the application DEV++. Our goal with this program is to provide a practical tool capable of truly analyzing relation set.
Relationship characteristics are widely accepted and have been studied by several generations of educators, but they are difficult in trying to determine these properties exactly based on certain requirements like reflexivity, symmetry, and transitivity. For example, students manually entering relation can easily make mistakes and get wrong results, which will ultimately make it harder for them to understand the subject. The creation of a program becomes crucial in order to solve the problems. These applications serve as a manual assisting users in entering the quality of set and the elements that go with them. Next, depending on predetermined criteria built in the program, the analysis examines the relation's quality, including its reflexive, symmetric, and transitive aspects.
So right now we're going to talk about the algorithm. So the first things first of our algorithm of our system, which to demonstrate how to reach the objective is that starting with the user have to enter the number of elements. And after entering the number of elements, we'll be proceed executing the looping statement where it will with the condition of if the set of number which are being entered by the user if less than the number of elements which the user have entered. So right now we're going, if it's complete, then we can proceed with entering the element to register the A and B for each element. And after the looping has finished, we'll be proceeding to our next execution, which is finding the reflexive in the relation. So in this algorithm, we'll be proceeding with finding the reflexive simply by making another looping, which is if the set of elements is less of the number of elements which are to be entered by the user, which is trying to find it. And then we will be proceeding with another condition, which is the element A is equal to the element B, which means the coordinate of the thing. So if it's equal to each other, then we'll be proceeding displaying the elements as the reflexive relation. And if it's not, then we'll be proceeding to another algorithm. Right now, the second algorithm will be to find the symmetric elements relation. So the first thing first, we have to start by the looping. Either is by the condition of if set is less of the number of elements. If it's yes, then we'll be make another looping inside of it as the subs element. So we can reconnecting to both element, making the condition if it's related with the first set of element with the subset of element, which is basically we'll be consider proceeding to another condition, which is the element B equals to subs element A, and elements A equals to subs element B. And if it's yes, then we'll be proceeding displaying both set of elements as its relation. And if it's no, it will be keep repeating until we'll be proceeding to a next algorithm. So right now we're going to proceed with another algorithm, which means to find the transitive of the elements, the set of elements, by simply making a loop, which by the condition of this if set is less than the number of elements which being entered by the user. And then we will create another loop, which is just to recheck if by the subs element we'll be creating another loop is either if it's connected to the first loop, which basically a loop inside the loop. And then we'll be proceeding with the condition is the element B equal to subs element A, or element A equals to subs element B. And if it's yes, we'll be displaying both set of element by which is the set of elements as we have been mentioned in the first place, and also as well with the subs element, which mean the elements in another looping inside of it. And then we'll be keep repeating it until, if the condition is no, then we'll be proceeding with the next algorithm.
The next algorithm in our system will be transition closure, starting with proceeding a looping with condition of if the number set of elements which are being processed are less than the number of elements based on the user input. Then execute another looping inside the loop with condition of whether if sub-element set is less than the number of elements based on user input. Each statement would be proceeding to a condition whether is element B is equal to sub-element A or element A equals to sub-element B. If it is a yes, then we will be creating a new set element where the new element A assigned with the element A along with assigning new element B with sub-element B. Finally, we will now display the new element which we have created. After that, we will be repeating in the loop until it finishes process the entire set of elements.
The next algorithm in our system will be the symmetric closure, starting with proceeding a looping with condition of if the set number of elements which being processed are less than number of elements based on user input. Then execute another looping inside in the loop with condition of whether if sub-element set is less than number of elements based on user input. In this statement would be proceeding to the condition whether if the element B is equals to sub-element A and element A equals to sub-element B. If it yes, then we will be creating a new set element where the new element A assigned with the new element A along with assigning new element B with sub-element B. Finally, we are now will display the new element which we have just created. After that, we will be repeating in a loop until it finish process entire set of elements.
And that was it. So right now we have acquired the output of GUI based on algorithm. We have set it up from the first with the C++ language which we have been using in our system to demonstrate about the relation of the reflexive, symmetric, transitive, and even not the transitive closure, reflexive closure, and symmetric closure, and even the transition closure. So let's proceed to the next point.
Next, I will explain about analysis. The analysis for this project concludes that R is a reflective, symmetric, and transitive relation as it satisfies all the corresponding criteria. Moreover, the assessment of relation closure encompassing reflective closure, symmetric closure, and transitive closure revealed that R does not require any additional pairs, since it already adheres to all the rules. Consequently, R can be categorized as an equivalent relation. Another scenario involves user input for relations such as R11, 21, 22, 31, 32, and 33. The program output indicates that the relation is reflective and transitive, meeting the rule for these properties but not for symmetry. The subsequent output lists that the reflective and the transitive closure. The program determines that the output based on the user entered element. If the entered element adhere to the specific relation rule, the display output corresponding to the relation with fulfilled rules. In conclusion, the program that have been established by our group can analyze the binary relation provided by user and efficiently check the properties of the user input relation if the relation is reflective, symmetric, and transitive, and print the output. Our program can prove if the input relation is equivalence relation by checking it reflective, symmetric, and transitive.